Here's a special example that at first looks difficult to approach. We need to solve the equation 2 sin theta is equal to cos theta in this interval here. So to do this, we need to make use of the tan identity that we talked about before. Tan theta is always equal to sin theta over cos theta. So what we're going to do for this 2 sin theta is equal to cos theta, we're going to divide both sides by cos theta to get 2 sin theta over cos theta is equal to, and this is going to cancel out and give 1. But because we know that tan theta is equal to sin theta over cos theta, this can be written as 2 tan theta is equal to 1. And then we can just solve this. So we can divide both sides by 2 to get tan theta is equal to a half, and then we can just solve this. So the first thing we can do is do the inverse tan of a half, which if you put this into your calculator is equal to 2 decimal places to 26.57. And then we're going to, in the interval 0 to 360, draw the tan graph. This is y and this is x. The tan graph looks like this. I'm not going to draw the asymptotes in because it's a very rough graph, so it's not too important. And half, we'll say, is about here. And we can see the 2 points here, one here and one here. This point is going to be the 26.57 that we've already found, and we know that the distance between this point and this point is going to be the same as the distance between this point and this point. So this distance here is 26.57, as this point here is 0. So therefore this distance is also going to be 26.50, and we know this is 180, so therefore this point here is going to be 180 plus 26.57, which if you put into your calculator is equal to 206.57. So theta is equal to 26.57 and 206.57. And again, you can put these solutions into your calculator, into this equation, in order to check your answers. Really quick, there's just one quick example that I want to go through that might look something like this. We have to solve the equation sin squared theta is equal to 3 over 4. So the approach that you might think for this, sin squared theta is equal to 3 over 4, is just to square root both sides and do sin theta is equal to, and it's going to be root 3 over 2 if you put it into your calculator. And that is the correct approach. However, one of the most important things you always need to remember is to consider the positive and negative square root. So it's sin theta is equal to plus or minus root 3 over 2. And we consider these two separately. So let's start with sin theta is equal to plus root 3 over 2, although we don't really need to write the plus. So we can do the inverse sin of root 3 over 2, which if you put to a calculator is equal to 60. And then we can draw a graph for this interval. Like this, where this is x and this is y. I'm going to say that root 3 over 2 is somewhere here. And there are 2 points, one here and one here. We know this point, this is 60. And this point here, we can figure this out because the distance between this point and this point is going to be the same as the distance between this point and this point. This distance is obviously 60 as this is 0. So therefore that's going to have the same distance over there. So it's going to be, this is 180, and it's going to be minus the distance, which is 60, to get this point. 180 minus 60, which put into a calculator equals 120. So we know that for this solution, theta is equal to 60 and 120. these 2 points. But we also need to consider that sin theta is equal to minus root 3 over 2. Now you could do the same process and do all of this. However, there is a much easier way to approach this, and this is to realise that if we say that sin of minus 3 over 2 is about here, what's actually going to happen is the distance symmetry is still going to apply. The distance between this point and this point is the same as the distance between this point and this point, which remember is 60. And we know that this is 180, so therefore this point here is going to be this point 180 plus 60. 180 plus 60, which if you put into your calculator, just figure it out, is 240. And the same logic applies here. This distance is going to be 60, and we know that this is 360. So it's going to be 360 minus 60, which is 300. So theta for minus root 3 over 2 is 240 and 300. So therefore theta can equal all of these values: 60, 120, 240, 300. Please remember the plus or minus square root. And again, we can put these back into here, these solutions, in order to prove and check that we've got the right answers. So here's a couple of questions on simple trigonometric equations. So pause the video, have a go, and I'll go for the answers in about 5 seconds. So for question 1 part A, the first thing that we need to do is to rearrange the equation 1 minus 2 cos theta is equal to 2. So we bring the 1 onto the other side to make minus 2 cos theta is equal to 1, and divide both sides by minus 2 to get cos theta is equal to minus a half. And then we can just do the inverse cos of minus a half to get 120. Now we're going to draw the cos graph between 0 and 360, which looks like this. We'll say minus half is about here, this being y, this being x. Remember that this is 90, this is 180, this is 270, this is 360, and this is 0. Okay, so we've got 2 points, and we know this point is going to be the 120 as it's below 180, and we need to find this point. Now we know that distance between this point and this point is the same as the distance between this point and this point due to symmetry. And we can figure out the distance between this point and this point, as this is 90, and we know this is 120, so this is going to be 120 minus 90, which is equal to 30. So therefore that is the distance between these 2 points, and we know this is 270, so this point here is going to be 270 minus 30, which is equal to 240. We can figure this out by knowing the cos graph. So therefore theta is equal to 120 and 240, and that's the answer. And again, you can sub these values of theta into the equation, and they give out 2 in order to check that you've got the right answer. So for part B, the first thing that I would do is I would rearrange it into the form cos theta is equal to something, because that's kind of the form that we're familiar with. So it's 1 minus 2 cos theta is equal to k. Bring 1 onto the other side to make minus 2 cos theta is equal to k minus 1. Then divide both sides by minus 2 to make cos theta is equal to k minus 1 over minus 2, which we can write by bringing the minus onto the top as 1 minus k over 2. So cos theta is equal to 1 minus k over 2. Now we need to find the equation where it has exactly one solution, and it actually says the value of k. So there's only one value. There's only one value of k in which this works. And the way we're going to do this is by making use of kind of the lines that we've drawn before, and that kind of shows us the amount of solutions there are. We need to find a line in which there's only going to be one solution, and you actually find that there's only one position on the whole graph that we can actually do this, and it is down with a line like this, where it touches like a tangent it touches this line once here, and this is at -1 because there is only one value between 0 and 360 where this is only equal to one solution, and this is where it's -1. Now, because it has these equal to inequalities, if it didn't have this, you could make an argument for it being 1 as well up here. But because we have these equal to as well, these points are included in the interval, and therefore it does touch both of them. So that's quite important. It might be an easy mistake to make, is to make a note of those intervals. But it's -1, so 1 minus k over 2 is equal to -1 in order to make cos theta equal to -1. We can rearrange this to make 1 minus k is equal to -2, and therefore it's going to be minus k is equal to -3, and therefore k is equal to 3. And that's the final answer. Okay, so for question 2, this is one of the ones where we have to make use of the identity tan of x is always equal to sin x over cos x. So the equation cos x is equal to sin x can be written as 1 is equal to sin x over cos x by dividing both sides by cos x, and then this can be written as, from up here, tan x is equal to 1. The inverse tan of 1 is equal to 45. Then we can draw the tan graph between -180 and 180. And we'll say that 1 is about here. We've got 2 points here. We know that this one is 45. This one here is 45, and we have this point here as well. And we know the distance between this point and this point is the same as the distance between this point and this point. This is 0 and this is 45, so therefore this distance is 45. So therefore this distance is also 45, and we know this is -180, so it's going to be -180 plus 45, which is equal to -135. So the two values of x are -135 and 45, and you can sub these values into this equation in order to check your answer.